Welcome to the video lecture of Compiler Design. This video discusses the topic Boolean Expression coming under Intermediate Code Generation of Module 5. This video pertains to the course outcome, translate high-level language into intermediate code, and design syntax-directed translation scheme for a given context-free grammar. The syllabus shows that Boolean Expressions is coming under the intermediate code generation. That means the Boolean expressions, how it is getting translated into intermediate code is discussed over here. The topics under the Boolean expressions are methods of translating Boolean expressions, numerical representation, short-circuit code, flow of control statement, control flow translation of Boolean expression, mixed mode Boolean expression. Usually this Boolean expression is a topic which is asked in a university question as a small essay for 7 marks, like that. Coming to the first introduction topic of the Boolean expression. Boolean expressions are used to compute logical values. We know that whether it is 0 or 1, like that, we have to compute the logical values using a Boolean expression. Also, it can be used as a conditional expression in statement that change the flow of control. We usually use this Boolean expressions in the flow of control statement like if, while, etc. Boolean expressions are composed of Boolean operators and, or, and not. Which are the Boolean operators and, or, not. And that can be applied to either Boolean variables or relational expression. Usually in if or while statement we can use relational expression. Then it can also carry this Boolean operators and, or not. Consider another Boolean expression generated by the following grammar. Capital E gives E or E, E and E, not E, E within bracket, ID relop ID, true or false. Here, one thing we have to note is that these are the possibilities where the Boolean expression can come. The different associativity and precedence for each of the Boolean operators. Here or and they are left associative. Not is having the highest precedence. Next precedence is for and lowest precedence is for or. Methods of translating Boolean expressions is important. There are two methods of representing value of a Boolean expression. First one is we can encode the value of the Boolean expression either as true or false numerically, and that Boolean expression will be evaluated similar to an arithmetic expression. Normally we use 1 for true and 0 for false, or you can say that any non-negative values can be used for representing true. Always the 0 represents false value. Another method for representing value of a Boolean expression is implement by flow of control. That is, represent value of the Boolean expression by a position reached in a program. When we use flow of control statement, it will represent the value of the Boolean expression based on the position reached in that program. That means it is used in if then statement, while, do while statement, etc. Example, if you are given an expression capital E gives E1 or E2, E1 evaluate to true if E1 evaluate to true, then capital E also will evaluate. Without having to evaluate E2, we can say that E will be true. That means only E1 is need to be evaluated if E1 is true. So we can avoid some operations over there. There is no need to check for E2 if E1 is true. Because 1 or 0, it will always produce 1. The result is 1. Coming to the details of the numerical representation, here we are considering an example A or B and not C. That is the expression, Boolean expression. The translation for the 3-address code is the not is having the highest precedence, so we have to evaluate that first into a temporary variable. T1 is equal to not C. After that, we have to give we know that the precedence is for AND. So B and not C have to be evaluated. So here the temporary address variable T2 is to be generated. T2 is equal to B and T1. Then we have to evaluate OR. T3 is equal to A or T2. Another is the relational expression A less than B is equivalent to, if A less than B, then 1, else 0. If that A less than B that holds, what is the Boolean value? It will be obtaining the Boolean value 1, otherwise it will be obtaining 0. And its corresponding translation in terms of 3 address code is shown here. It is shown as different statements, and the statements can be labeled as position 100, 101, 102, 103, 104. So starting from the 100, they will be generating if A less than B. If A less than B is true, you have to go to 103, the step number label 103, that is the statement number 103. There we are setting T as 1. In the case of 101, if A less than B is false, it will normally go to the next step, that is 101. There T will be assigned as 0. So if A less than B is false, that means we have to execute the else part. So else part, that means go to 104. That may be in the statement labeled 104. So that is the translation for the relational expression in that use Boolean values. This slide shows the syntax error translation of Boolean expression. Here also emit is the function used to produce the 3 address code output. Emit places 3 address statements into an output file in the right format. That next stat gives the index of the next 3 address statement in the output sequence. Here, one thing you have noticed that there is a variable called next state, that is next stat, that will hold the index of the next 3 address statement in the output sequence. What is the next 3? The sequence, that is the label or the index of that 3 address statement is stored in next state, and that emit increments next state after producing each 3 address statement. Then we can see that with the help of these expressions, here the expression can be even or E2, even and E2, not even, then that even within bracket. That means here expression can be provided within bracket. Then ID1 rel of ID2, then E can be true, E can be false. So here if E gives E1 or E2, that is E dot place is equal to new temp. We have to generate a temporary variable for storing the value of E. The emit E dot place will be having E1 dot place or E2 dot place. Then E gives E1 and E2, E dot place will be new temp, and emit E dot place equal to E1 dot place and E2 dot place. So that operators will be maintained as such. In the case of E gives not E1, E dot place equal to new temp, and emit E dot place is equal to not E1 dot place. Then that we have seen in the previous example. So this type of translation happens to the statement like that we have shown in that previous slide, A or B and not C. So this 3 address codes will be generated if we have this syntax error translation scheme. Then in the case of E is within a bracket, E dot place equal to E1 dot place. In the case of ID1 rel of ID2, that means if it is occurring within a flow of control statement, E dot place equal to new temp, emit if ID1 dot place rel of ID2 dot place go to next state plus 3. So here when we consider the previous example, A less than B. If A less than B, then 1 else 0. So the translation is if A less than B, go to 103. We expect to start at 100. So E dot place equal to new temp, that is T1. And emit if ID1 dot, ID1 is A dot A, rel of relation operator is less than there. So if A less than, ID2 dot place is B, go to next state plus 3. So next state is 100 now, 100 plus 3, that is 103. So that is why there it goes to 103. emit e dot place equal to 0. Emit go to next state plus 2, that is now it is t equal to 0. Then it will be incremented and now it is at 102. So emit go to next state plus 2, 102 plus 2, 104. Emit e dot place equal to 1. So go to 104, t equal to 1. So that will be displayed in the output file. Then we can see that t is equal to 1, so that will be displayed. So this is the syntax directed translation scheme for the Boolean expression which is having a relational operation. Within the flow of control statement, say if. Then the expression's value, finally the expression will be having a value e dot true. E is having a value, it can be true. That means it will generate e dot place is equal to new temp, emit e dot place is equal to 1. E is false means e dot place equal to new temp, emit e dot place equal to 0. Then this is another statement, that is the translation of for a less than b or c less than d and e less than f. So here it will compute if a less than b, then go to 103. t1 is equal to 1. That means if a is less than b, it is correct, the true value 1 will be assigned, otherwise that will be false. So t1 equal to 0. And then you go to 104. So to check c less than d. C less than d, go to 107. 104 plus 3. So 107. 107 t2 equal to 1. That means if c is less than d, it is true. The true value will be assigned. Otherwise it will be 0. Then go to 108 means we have to check it with e less than f. So if e less than f, go to 111. Then if that is true, it will be going to 111. 111 at t3 is assigned 1, otherwise t3 will be 0. Then you have to perform the OR operation or AND operation. Here AND is having the highest precedence, so AND you have to perform first. So what is the result of c less than d? That you have to AND with the result of e less than f. That is why t4 is equal to t2 and t3. Then t5 is equal to the result of c less than d and e less than f, and then OR it with the a less than b. So that is t1 or t4. Next topic is short circuit code, jumping code. In the case of short circuit code, we can translate Boolean expression without generating code for Boolean operators. Also, we may not be required for evaluating the entire expression. So it will not arise the need for evaluating the entire expression. Here we can explain it. Translation of a less than b or c less than d and e less than f. This is the previous example. Here we can say that if a less than b itself is 0, that means this, if a less than b, go to 103, then t1 is equal to 0, go to 104, t1 is equal to 1. So if a less than b is true, you have to go to t1 is equal to 1. We know that c less than d and e less than f, it will be having some 0 or 1 value. So if a less than b is 1, you have to OR it with that result of that c less than d and e less than f. Whatever be the value, that is either 0 or 1. If a less than b is 1, we may ensure that the value of the entire expression can be made as 1. Because OR operation allows 1 or 0 can be 1. 1 or 1 can be 1. So if a less than b is having 1, it makes sure that the entire expression will get evaluated true, always 1. So we can avoid this generation of code for Boolean operators. This AND is not required, OR is not required, and also the entire expression need not be evaluated. From evaluating a less than b itself, we can get the result of the entire expression. If a less than b is 1, that means if a less than b is true, it says that the entire expression is true. So that is called as short circuit or jumping code. Next is flow of control statement. It is used with the if then else, while. So here the statement means that if expression is true, then you have to execute the statement S1. This can be called as the statement S. Or another alternative is if expression is true, then you have to execute S1. If expression is false, you have to execute S2. While do S1 means you have to compute the expression. If the expression is true, you have to do S1. Otherwise, you have to go to the next statement after the statement S. So in the translation, it is assumed that a three-address statement can be symbolically labeled. In the case of the flow of control statement, its corresponding translation scheme holds some symbolic labels, and a function new label returns a new symbolic label each time it is called. Similar to the temp, there is a new label function which can return new symbolic labels. With the Boolean expression, two labels are associated. In the case of flow of control statement, E dot true and E dot false. E dot true, the label to which control flows if E is true. The label to which control flows if E is false is E dot false. Similarly, S dot next is a label that is attached to the first three address instruction to be executed after S dot code. So after this code of S, code corresponding to that S, there will be next statement. So that statement's code will be stored in S dot next. Here it is explained the code corresponding to the S. It is if E then S1. So there will be two labels, E dot true and E dot false. E dot true will be assigned with a new label because while we execute or evaluate the expression, the code it will be generating two labels, E true and E false. It can be E true or it can be E dot false. So E dot true means we have to evaluate the S1 dot code. So that is here pointing to S1 dot code. We have to execute that S1. If E is false means it has to go to the next statement after that S. So E dot false is assigned as S dot next. Then what will be S1 dot next? After the S1 code also it will be pointing to the statement after S. So S1 dot next is equal to S dot next. So what will be the code of S? S dot code is equal to the concatenation of E code, E dot code, the code of E, then generation of E dot true, that label, then S1 dot code. So that will be the code corresponding to the statement S. If E then S1. Another one is if E then S1 else S2. So here expression will be there. The code will be having two labels, E dot true and E dot false. If E dot code is true, it will go to the S1. So here S1 dot code. If it is false, it will go to the S2 dot code. Then after S1, it should go to the statement after S1. So S. So go to S dot next. So after S2 also it should go to S dot next. That is shown here. E dot true is equal to new label. E dot false is equal to new label. S1 dot next is equal to S dot next. S2 dot next equal to S dot next. The code for S will be the concatenation of expression code. Then generation of E dot true. Then S1 dot code. Then it is combined with the go to S dot next. Go to S dot next. That means after the code it have to go to that go to has to be there. Go to the code which is after that S. Go to S dot next, then E dot false, then S2 dot code. That is the code for the S if E then S1 else S2 statement is translated. For the while expression do S1. So here also the E dot code will be evaluated. Then it will have two labels, e dot true and e dot false. E dot true will execute s1 dot code. E dot false means s dot next. So after that s1 also, what is the thing you have to do after the s1? That means if it is true, you have to execute s1. Then again you have to, since it is a while loop, you have to come check the expression. So you have to go to s dot begin. So if it is false only, we can jump to the statement after x. So that is shown here, s dot begin equal to new label. There is another label begin. S dot begin equal to new label, e dot true equal to new label, then e dot false equal to s dot next, s1 dot next equal to s dot begin. These are the new labels. So the code for it will be gen s dot begin, then e dot code, then e dot true, then s1 dot code, then go to s dot begin. Next is the control flow translation of Boolean expression. In the flow of control statement, the Boolean expression will be there, how it will be get translated. That we are observing in the coming slides. E is E1 or E2. That means expression 1 or expression 2. You know that as we have said previously, if it is an OR statement, 1 or 0 or 1 or 1 can always result in the true value for that entire expression. So here if E1 is true, we can straightly say that E2, E dot true will be the result. Then E1 dot false will be new label. If it is false, we have to evaluate E2. E2 dot true is equal to, if E2 is true means expression will be true. If E2 dot false is false means E dot false. So the code for E will be E1 dot code, generate E1 dot false, then E2 dot code. So if we need to generate the code for capital E, we have to generate the code for E1. If E1 is false, we have to execute E2. Then similarly E1, E is E1 and E2. E1 is 0, it means the expression will go always 0. The entire expression will be having a false value then if E1 is 0. So here E1 dot true is equal to new label, E1 dot false equal to E dot false, E2 dot true. That means E1 is true. Then we have to examine E2 dot true also. That is E dot true. If both of them are true, it will be E dot true. E2 dot false is equal to E dot false. So the code for E will be E1 dot code. That means you have to evaluate the E1 dot code. If it is true, you have to generate E1 dot true. Then you have to execute E2 dot code. Not E1. Here, if E1 dot true, then it will be the negation. So that will be assigned the false value. E1 dot false means it is assigned the negation, that is E dot true. So the code for E will be the code for E1. Here also E1 dot true, E is E1 within bracket. What the expression's logical value will not change. It will be assigned E1 dot true equal to E dot true, E1 dot false equal to E dot false, E dot code is equal to E1 dot code. Then if the expression E is of the form A less than B, then code is of the form if A less than B, go to E dot true, go to E dot false. So the translation will be based on this. E is ID1 relop ID2. So that is E dot code is equal to generate if ID1 relop ID2 go to E dot true. Then generate go to E dot false. That means if it is that relation is true, that means entire expression will be true. Otherwise the entire expression will go false. It is that expression is of the form is a relational operator. If A less than B is true, then go to true, otherwise false. That is E is true, E dot code is equal to gen, go to E dot true. E gives false, then E dot code is equal to generate, go to E dot false. That is why. So if that expression's value is true, what we have to generate? Then here, this is the same example that we have considered previously. A less than B or C less than D and E less than F. Here we are evaluating only A less than B. If A less than B is true, go to L true. That means the entire expression's value is stored in L true. So that can be made as true. Then if it is false, go to L1. L1 will evaluate C less than D. Then we have to go to L2 if it is true. That means if C less than D is that means if A less than B is 0, we have evaluated it. That is why we have gone to L1. Then C less than D and E less than F. In the case of AND operator, if C less than D itself goes to 0, that means the statement will become false because it is already false. So it will become L false. If E less than F, go to L true. If it is true, you have to make it true because this is 0. And the C less than D and E less than F, it is evaluating to true. E less than F is evaluating to true. And that gone when C less than D is also satisfied. So both of them are giving a one value. That means the entire expression's value become L true. Otherwise go to L false. Then L true and L false you have to generate. Another example is while A less than B do, if C less than D, x equal to y plus z, else x equal to y minus x z. So if A less than B, then here we have to perform C less than D. So L2 you have to perform C less than D. If A less than B is false, that means the entire L, this has to be, the statement after this L has to be executed. That is why go to L next. Then if A less than B is true, we have to evaluate C less than D. That means we have to evaluate this expression T1 is equal to y plus z. Then if C less than D is false, means we have to evaluate x equal to y minus z. That is why it is given like that. X is equal to T1, go to L1. That is, if C less than D, then you have to execute x equal to y plus z. That is T1 equal to y plus z, x is equal to T1, go to L1. That is because this is a while statement, you have to repeat it. Again you have to examine that. If C less than D is false, means go to L4. We have to compute y minus z. T1 equal to y minus z, x equal to T1, go to L1. Again you have to check since this is a while statement. If A less than B becomes false, then only we can go to the next statement after the entire while loop. The last topic is mixed mode Boolean operation. In the case of mixed mode Boolean operation, it can have both arithmetic as well as Boolean expression. Here we are considering the expression E gives E1 plus E2. E1 can be arithmetic, E2 can be Boolean. In such occasion, we will be having that E dot place for arithmetic expression, E2 dot true and E2 dot false are the attributes for Boolean expression. Then the code generation will be E2 dot true. That means E1 will be arithmetic, E2 will be Boolean. So if E2 is evaluating to 1, then E1 dot place, whatever will be the value of E1, that will be added with this value 1, which is generated by the Boolean expression of E2. And go to the next statement plus 1. If it is false, means if E2 is getting false value, only because that value will be 0. The value of E2 corresponding to E2 will be 0. That means only E1 need to be evaluated. That is why E2 dot place is equal to E1 dot place. Thank you. That is all about Boolean expression.